Almost forgot to turn that on. The volume of a solid is a known integratable cross-section A of x. From x equals a to x equals b is the integral of a from a to b, which means to find out what the area is, what the volume is, I'm summing up all these little pieces, right? All these little areas over and over and over again, times my delta x, which is the length of each of them, how wide they are, in order to get, if I sum those up, that will also give me my volume, which we can then rewrite as, well, we always know we can rewrite summation as integration as long as we have that delta x there and some form of function here. So the volume is equal to, from a to b, the integral of ax times dx. So you take the area formula, multiply it by dx, which again, just the integrational portion, and you would find your volume. Now, how to find a volume by the method of slicing. The first thing you need to do is sketch the solid and a typical cross-section. Then you need to search deep into your brain and try to remember what your area formulas are. What's the formula for a triangle, square, circles? I don't think they really get harder than that necessarily. The very basic shapes. Drawing it out is going to be the hard part. Then you want to find the limits of integration. Then you want to integrate a of x to find the volume. Now, the hardest part of this is not the math. I even talked to Mr. Miller, and probably you can talk to Roland. The hardest part is drawing these things.
Yeah.
The integration is easy. I know you all can integrate these. Setting it up, finding out the equations, and making sure you understand exactly how it happened is going to be the hard part here. So, this is also very hard for me because I have to draw. Okay. So, let's go ahead and look at different volumes using different cross-sections. Let's say we have square cross-sections. Well, think about it. If you have a square and then a square that gets smaller and smaller and smaller, what shape does that make? A pyramid.
Oh, man.
Everybody laugh at Connor real fast.
All
right, good.
You're left.
Good. Anyway. All right. No, but I thought the same. I mean, I did go like this, so it wasn't a perfect square. So my hands look like a circle, but I said square, so I'm not going to count you off too much. So if I have this graph here, and then let's say I have a line like this. A lot of the times they will either give you one line or they will give you two lines. If you have one line, you have to rotate it yourself. But if they give you two lines, you do not. So I'm going to draw out this other one. You will almost always have this almost the same shapes here. And now we just want to give it squares. So I'm going to draw this out as a pyramid here. This is what it looks like here, here. No, yeah, that's good.
Paper air from wall.
Boom. Boom. Or, let's go a little bit. No, that's about as steep as I went there. Boom. 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 Do you all see the squares that I created in here?
Wait, that's pretty good.
Huh? It's not bad, isn't it? Trust me, they get crazy. I actually went on, I think this is the longest my nose took. I think one picture took me like 15 minutes to draw at one point because I kept messing it. Like I said, I'm not great at drawing these, but I kept messing them up. Okay, so that is a square cross-section. Now a solid of revolution. This is one of the easier ones. It is just going to be a this one is a cone. Oh no, I can draw that there. Expand it out. So, in order to do these, we need to determine what our area is. Then we would need to determine other information about it and then go from there. We'll get over more of that tomorrow. Today, we're not really necessarily focusing on that. And here's the hard one. This one is difficult to look at. Okay. This is the washer cross section. All right, let's see if I can do it. So this is where you need to have multiple functions. So let's say we have this function here. And then we have this function here. Actually, I'll do this in a different color. That'll work out well. Okay? Now, if you look at this, this is our empty space right here.
Oh, what's the center of the donut?
This is like the center of the donut or the center of the washer. It's just that it's a different size. So when I draw this out, I will almost always draw a circle in the middle like this. That is your empty space.
How are these even functions if they don't pass like the VLT?
The VLT, because we now know how to write them as functions defined as y, remember? So now, if you turn your head, if you go ahead and look at this and turn it this way, does it pass the VLT now? Yep, it does.
I see.
And these are also two separate functions. You have this one and then this one, right? So therefore that's it. So then, what does the top of the washer look like? We have this here. So from here, all the way around. Do you all see that washer that I've drawn now? The washer, the actual part of the washer is this here. Remember, this is a three-dimensional shape on a two-dimensional graph, so it's going to be hard to
How
see.
did you conclude the claw thing?
Huh?
How did that? Where did the claw thing come from?
This is just the functions. Here's this function and that function.
And you're drawing a donut.
This function and this function, and we draw the donut in there.
Wait, I think you just made a cone and then.
Because this is how the area is. This is what we need to do for this area.
uh,
Okay, so now if you do the bigger one, you can do another bigger one over here with a big circle here, and then you do from here to here. That is that washer. As you can see, my drawings aren't getting amazing, but that's okay. Make sure you can understand how to draw these yourself. That is the important part, is can you draw these yourselves?
Oh my god.
Probably not the last one. Potentially.
The last one you will definitely have to practice on. Now let's actually do one of these, And this is interesting because this is how we're actually going to develop a lot of our volume formulas. The volume of a sphere. Do you know how we came up with that? Well, people obviously did some trial and error. They understood that there was pi. We can use calculus to develop it. How about the volume of a cone? Do we know how to came up? Why is the volume of a cone? What is it? one third pi r squared h, right? How do we come up with that?
Calculus.
Calculus.
Oh, yeah.
Well, we found one. So, what house are you in?
Beethoven.
Wait,
Oh,
Emma's
demerit.
getting in there?
Yeah, the demerit. There you go. Yep, sorry, Colin, that's a demerit. No, I was gonna say, well, if you were in the same house, I wasn't gonna do anything. But since you're not, I might just give them a merit. Maybe. Anyway, a pyramid.
Whoa, bro.
So if you have, so here's the funny thing: if you know what the formula for a pyramid is, this is actually a very easy problem. Like I said, it's 1/3 pi. Oh, sorry, this is a pyramid, so it's 1/3 base times height. So 1/3 the base times the height. A pyramid, 3 meters high, has a congruent triangular sides and a square base that is 3 meters on each side. Each cross section of the pyramid parallel to the base is a square. Find the volume of the pyramid. So let's go ahead and draw this out. We know it's a pyramid. Has congruent triangular sides, which just means basically that it's a pyramid. That's just a definition of a pyramid. You don't really have like a tilting pyramid. You'd call it something different. But let's draw it out. We have this here, this here. Just draw your axes, right? And I'm going to go ahead and draw this. If you looked up here, how did we make this cone up here? This pyramid here, we used squares and we used a linear function. So I'm going to do the same down here. I'm just going to draw this out like so. Draw this out like so. And I'm going to give it a square base. So boom. So oops. Boom, boom. Boom, boom. Okay. So what happens when we look at this, we have to be careful because we know this here. They haven't really given us a ton of information. Thankfully, we can use what we know already. I look here and I say, well, what is my shape? What's the actual area I'm finding?
Square.
A square. And what's happening to the square? The square is getting
Bigger.
bigger. So can we just use any old function for this? No, we have to use integration because we want to add the area in between these two. So what I'm going to do is I'm going to draw this out. I know this is what I'm finding the area of. A shrinking or expanding square, right? Depending on which way you're going. We know that the square base is 3 meters on each side. And we know how high is it? What's this point right here? That is 3, because it tells us that it has a height of 3. Now, should I? Oh, sorry. Oops. Yeah, sorry. Oh, not sorry. These are not 3 and 3. That's my apologies. This here is 3, and this is 3. But do we know what these two are right here? No. So we call those x and x. Because what is the area formula? A of x is going to equal sides squared. And since our sides are x, we call that x squared. So we get a of x equals x squared, which equals x squared. Well, now we can just make our actual volume formula. V is equal to what? Where do I start this? Right here. I start this at 0. Then I go all the way to 3. So I go from 0 to 3. Then we're doing a of x dx. What's my a of x going to be? X squared dx.
What happened to the 1/3?
The 1/3.
Is that not? Well, because that's the area of the pyramid.
I know, but now let's integrate. No, that's the volume of a pyramid.
Oh, yeah.
Let's integrate now. What do we integrate x squared into? X cubed over 3. Do you see where the 1/3 came in now?
I do.
There we go. And so then we do x cubed over 3 from 0 to 3. 0 cancels out. So we get 3 cubed over 3. Makes it 3 squared, which equals 9 meters squared. Now if you actually did this with the formula, what is the area? It's the area of the base times the height times 1/3, right? The volume formula is V equals 1/3 pi, sorry, not 1/3 pi. 1/3 area of the base times the height. What is the area of the base going to be? Well, the area of the base is 3 times 3, which is 9 times, what is the height of this pyramid? 3, which will equal 27 times 1/3, which is
He just canceled.
9.
I don't know what he did.
So do you see how we developed this right here? Now,
He did.
what is the height? The height is always going to be whatever number's up here. If you have a height of 3, then it's going to be from 0 to 3. Height of 5, it's from 0 to 5, and so on and so forth. Okay? It's all right if you're struggling a little bit conceptually. We will have a lot of time to work on these in class specifically. Today, your homework is 1 through 3, and I'm going to give it to you pretty much right now. So you'll have quite a bit of time to work on the homework. We have 5 days in this section, so get comfortable with just drawing and graphing and drawing and graphing. Okay, your homework for today, we're going to work on, let's just work on 1 through 3 and see how far we get. We're just going to work on 1 through 3 and see how far we get. All right, Evie, goodbye. Is there a message we should send to Isaac, everyone?
Come see me at In-N-Out.
Come see JJ at In-N-Out. Yeah, what days do you work In and Out?
Thursday, Friday, Saturday this week.
All right, sweet. Well, you might get mobbed by all the people who watch my videos, just so you know.